Okay, so in this video we're going to look at absolute value inequalities. In absolute value inequalities, we have to understand that the absolute value changes things, and what it ends up doing is it makes it a complex inequality. There are other videos out there that can explain to you the exact reason why, but I'm just going to go through the procedure here. And that is, if you have the absolute value of something like x, and it's less than a number, or this could be absolute value of an x less than or equal to the number. It doesn't matter, less than or equal are treated the exact same way. If that's the case, then the way we get rid of the absolute value is we write the inequality just as it is, x less than a. And we have to learn that less than makes it an and inequality. And means both inequalities have to be true. So x less than a and x, and then here's the key. Instead of less than negative a, it's actually going to be change the sign of the inequality to greater than and negative a. Like I said, there's some videos out there that can help you show why this is, but for now, just accept it's going to be x less than a and x greater than negative a. Same thing on this one, except that it would be, you just have the less than and equal to. So less than is always going to be an and inequality. If you have greater than, it's the same idea where you write the inequality just as it is, and then you're going to change the direction of the sign from less than to greater than and make it negative a, but this time it's an or inequality, which implies that only one of the two inequalities has to be true. And so if it's greater than or equal to it, it's the same idea. There's nothing, the only thing that's different is that the greater than or equal to, so you got the equal to part. Okay, so these are your two things that you need. To solve a couple examples with this, we've got 11. Now 11 is an absolute value, but the absolute value instead of being x is x plus 3, but you treat it the same way. So it's greater than, so we go back and we use this. So we're going to start with x greater than x plus 3 greater than 2. That's our first inequality. Then because it's greater than, we saw that it's an or inequality. And then you change this direction of the sign, so x plus 3 less than, and then change the sign of the number to negative 2. So x plus 3 less than negative 2. Now, solve both of these inequalities. They get solved the same way. And you end up with x greater than negative 1 or x less than negative 5. And that is your solution. This is the actual solution. It's all the numbers greater than negative 1 or less than negative 5. It's actually two different regions of our number line. If you were to graph it, it would look like this, very quickly sketched. A negative 5 there, a negative 1 there. We put open circles because it's not equal to. Less than negative 5, greater than negative 1. And it would look like that. And number 12, it's already solved for the absolute value, so you do the same thing, 4x less than or equal to 8, but because it's less than this time instead of greater than, you've got to put an and in there. And then the other one is the same thing, except you change the direction of the sign to greater than or equal to, and change the sign of the 8 to a negative 8. Divide both sides by 4, you get x less than or equal to 2, and x greater than or equal to negative 2. And that is your solution. So it's all the numbers that satisfy both of these inequalities, which if you look at it on a number line, means that it's got to be numbers, and this is closed circles, in between negative 2 and 2. Because numbers in between those two are less than 2 but greater than negative 2. And that's how you go through and solve absolute value inequalities. Always make sure that you write two inequalities once you have the absolute value solved for.